Welcome to this presentation on single pass microprocessor. This is an example of assembly language program which is having the macro definitions and call to the macros. As it can be seen, this is the first macro definition, second macro definition, and in the second macro definition is the nested macro definition of the third macro. Now we'll be discussing the need of single pass microprocessor. Till now we have discussed the two pass microprocessor. So when a macro definition is within other macro, the inner macro is defined only after the outer macro is called. However, in case of two pass microprocessor, it has two separate passes, the first pass for definition and second pass for call and expansion. These two passes are separated. Hence, the macro definition within other macro cannot be handled by a two pass microprocessor, and we need to repeat both the macro definition and macro call passes. Hence, a single pass microprocessor is needed which will perform the macro definition pass simultaneously with the macro expansion pass. Data structures used by the single pass microprocessor are same as the two pass microprocessor, that is macro definition table to store the definition, macro name table to store the name of the macro name table pointer to indicate the current available entry in the macro name table, macro definition table pointer to indicate the next available entry in the macro definition table, and argument list array. In addition to that, it makes use of macro definition input, which is like a flag and which is set to on during expansion, and otherwise it is set off. It is set on while reading lines from MDT and set off after MN. Macro definition level counter is incremented by 1 after macro and decremented after MN pseudo op. For performing macro definition and macro call simultaneously, two separate ALAs may be required, one ALA for definition and the other ALA for expansion. Now we'll discuss the single pass microprocessor with this example. So the first macro definition which is encountered, so its prototype statement is stored in the definition table, argument A is stored in the argument list array, name of the macro is stored in the name table with the pointer indicating the entry in the macro definition table. Then we store the actual definition into the definition table by replacing the argument by its number in the argument list array. Hence, ampersand A is replaced by its argument number here. Then we find the second macro definition. So the first step is to store the prototype statement to the macro definition table, store the argument to the argument list array, and then store the name with the entry in the location number of the macro definition table, which is stored here as MDT index. Then we store the entire macro definition to the definition table, and here the ampersand sub is replaced by the argument number, that is #1 and #1, and the definition is stored into the definition table. Then it's as this is single pass microprocessor, there is no intermediate code, and it now starts with the expanded code. Start is stored in the expanded code. Then define cause, which is the call to the macro define. Hence, we detect its name in the macro name table. Then we find the position of the macro definition table. So it goes to the index position 4 in the macro definition table. Now this is call. Hence, the expansion will be done, and the expansion it detects the inner macro which is defined here. So for the inner macro which is to be defined, so the #1 which becomes cause, so cause and ampersand y, which is the prototype statement, goes to the macro definition table. Then the argument For definition is ampersand y, which goes to the separate ALA, which is storing the argument y, and now it goes ahead with the expansion, that is the code will be stored into the it will go ahead with the definition, and this code will be stored into the definition table. Hence these lines which are stored in the definition table, but here hash 1 is replaced by cos, hash 1 which is replaced by cos, and the ampersand y which is replaced by hash 1. So we have used two separate ALAs because here the definition and call, both the passes are going simultaneously. The call and the definition, these two passes are going on simultaneously here. Then it goes ahead with the amend, it ends with the definition process, and then the next statement ADC90 is stored into the expanded code. After that it detects the next call to the macro. So it finds the macro in the name table. Then it finds the position uh, in the macro definition table. This must be 14. Then it stores the argument A to the argument table. Then the code in the macro definition table is expanded and it is stored into the expanded code. Now here hash 1 will be replaced by the argument A, hence the hash 1 becomes A here. So the expansion for the call is done. Now it finds one more macro call, that is XYZ loop. So it first of all detects it in the name table, then it finds the position in the definition table, then it goes to that particular location, and now here the argument is loop, which is stored into the argument list array. Now it will start with the expansion, so lines in the macro definition till amend will be stored in the expanded code. Hence we have stored st1 and hash 1, which is loop. So the argument loop is stored into the expanded code. Then it finds end, and with the end it will stop the expansion of the macro, and it has generated the expanded code for the given assembly language program. This is the name table and this is the definition table. Reference for this presentation is the book on systems programming by J.J. Donovan. Thank you.